All right, so there are 4 of us on this research project and we're all going to participate in the presentation. I'm going to introduce the project a bit. Jaeon's going to show you how to use the tools that we used. Misbah's on the chat if you've got any questions or comments, and Byron is going to talk to you a little bit about the evidence from student work. So this is the context that we're working in. One of the things that makes us different from lots of sixth form colleges is that we do GCSE resit for all students. So at many sixth form colleges, you have to have a grade 3 to be allowed to do GCSE resit, and other students do functional skills or entry-level qualifications. Everyone does GCSE resit at Leighton Sixth Form College, whatever grade they've come in on. And so we've got some students who've come in with no grade or grade 1 and 2 who've really struggled with maths. And our project was focused on those learners and building their conceptual understanding. We focused on using key diagrams to build conceptual understanding, and because you need to teach diagrams, we focused on just 2 that can be transferred into different contexts. That's double number lines and bar modelling. There's good evidence to show those work. Yes, we will. There's good evidence to show that those work from other key stages. So we wanted to try them with these learners. Our methodology was a lesson study approach. So we planned collaboratively, we all delivered the lesson, we reflected together, and we did an assessment with the students, which was a Google form survey. The topics that we taught were ratio, proportion, speed, and equations. Over to you, Jaeon.
Thank you. So here's a proportion exam question. This is not a straightforward proportion question, but I'd like you to have a go and just have a think about what mistakes students might have made during this question. It's 3 marks. I'll give you a minute to try this question. Once you've worked it out, please just write in the chat any misconceptions you think, mistakes students would have made along the way. Okay, so the solution for this question is 40 biscuits. That's the greatest number of biscuits Anna could make. So hopefully you got that. I'm going to now show you how to use double number lines, or DNLs for short, in proportion questions. So here's an example. We've got 6 pencils cost £1.50. How much do 3 pencils cost? Just going to grab my pen. Okay. There we go. Okay, so first of all, when we're using DNLs, we tend to label the 2 variables. So this one will be pencils, and this part will be cost. So 6 pencils, I'll just put 6 here, represent £1.50. And therefore 3 pencils, obviously 3 is less than 6, so it helps students to see where the numbers would go on a number line. And what does that represent? So the easiest method would be to divide by 2 to get from 6 to 3, and therefore do the same thing to the bottom, which is to divide by 2 to give us 75p. An alternative method would be, again, just labeling your section. So pencils and cost, 6 pencils equals £1.50. So that's moving across the lines. We can also move between the lines. So what would 3 pencils cost? So going from 6 to £1.50, we times by 0.25, and therefore do the same thing to R3. Again, this will be on a calculator paper to get 75p as our final answer. So this helps students to kind of understand where the numbers will possibly go, and also giving them options of different methods they can use. So I'd like you to have a go with these 2 questions using a double number line, just to see how students would also try and answer these type of questions. I'll give you a minute to try that. Okay, and here are your solutions. So you should have got to 25 miles for the first one and 50 meters for the second one. Over to you, Byron.
Okay, thank you. So here's an example of a student's attempt at that biscuit question that we showed you a couple of slides ago. And you can see how
so you're muted, Byron.
Can you hear me?
Yes,
No?
we can hear you, Byron.
You can. So I don't know what happened there. Sorry. So here's an example of students' answers to the biscuit question that we showed you a couple of slides ago. And you can see here how they've managed to use it to support them in attempting a question that they wouldn't necessarily have tried even before. A reminder, this is for 0 to 2 grade students. But you will see, obviously, that there are slight issues in their answer that meant they weren't necessarily got the totally correct answer at the end, but they would have got certain marks on it. And this is a process that we went through, is getting them to practice the structure of drawing the double number lines and getting the numbers in the right place, and then the idea of how to move around the double number line to find missing numbers. So it was definitely a process that they developed over the year. Okay.
So now we're going to look at a ratio exam question. Again, this is not a straightforward ratio question, but I'd like to give you a chance to just try this question out. And then I'm going to show you how it's used using bar modeling. You've got a minute to try this one. Also, if you can write in the chat what percentage of your students you'd think would attempt this question. And again, any misconceptions or mistakes that you think students would make in this question as well. Okay, hopefully we've got to the end. So the solution here is 18 stamps for this question. And then I'm just going to show an example of how we use bar modeling for sharing in ratios. So here's your first example. So we've got share 240 in the ratio 3:7. So first of all, we would draw 3 boxes on the left and 7 boxes on the right. Just grabbing my pen. So this will be the 3:7. We've got 240. 240 represents the whole box. So I'll use some curly brackets just to show that 240 represents all the boxes. And this will help the students to visualize that they are dividing by 10 boxes to find out what each individual box represents. So we've got 240 divided by 10, which is 24. So then 24 will go into every box. You get the students to write that in. And therefore, they can easily see how much the first person gets and how much the second person gets. So 24 times 3, they can work that out, adding it up or doing multiplication, and 24 times 7. And we get 72 to 168. Another example would be this one. Noah, Ben, and Jen share some Easter eggs in a ratio 2:5:7. Ben gets 60. How many do Noah and Jen get? So again, the same idea would be to just draw the boxes, 2:5:7, labeling your boxes. So this one represents Noah, this is Ben, this is Jen, with your colons. And so Ben gets 60, so therefore I'll do the curly brackets around Ben only to represent that that is 60. So therefore, if that section only represents 60, then I need to split 60 into 5 boxes. So that helps students to see that we're doing that type of calculation, 60 divided by 5, which is 12, and then get them to write 12 in every box. Lovely, so Noah, he gets 24, and then Jen gets 84. So that's the solution there. So I'd like you to have a go at trying using bar modeling for these 2 questions. Again, I'll give you a minute just to try that. So I know that a minute is not a long time, but hopefully you get the idea of using the visual representations of these bar models to help students understand what's happening with the ratios. So these are the solutions here, 90 to 150. And in the second example, we've got Jane, which gets £28. Over to you, Byron.
Okay, here's another example of a student answer. So this was part of an assessment we did in November, so a formal assessment. This is the question you looked at just briefly before. Is question 23 on an exam paper, and given the complexity of the fact it's 2 ratios and then something to pick out at the end, you wouldn't expect many of our 0 to 2 students to even attempt the question, let alone do well on it. So we've managed to find one with a student who got full answers on it. But we did a survey as part of some data collection we did for all the topics we use these models for. So this is one example, and I think the thing you can see here is that of the students that we got using the BAR model in this assessment, which was a stage forward, a lot of them would use it in class, but not all of them would then use it in assessment, and they got better at that throughout the year as we supported them to do that. But you can see that 92% of those got at least 1 mark. Okay, so it's not necessarily getting the whole thing right, but they started to get marks on a question. Whereas if they did attempt the question and they didn't use a BAR model, then only 53% of them got at least 1 mark. And I think that was very encouraging for us, that this was helping them go in the right direction.
Okay, so to sum up, these are our key findings. Firstly, that double number lines and BAR models can be used to support reasoning in a wide range of GCSE maths exam questions. We use these 2 diagrams for 4 lessons as part of our project, and also for a couple of lessons outside of the project on fractions and percentages. The second main finding is that it is really worth taking the time to teach students how to use the diagram. It's a skill that you're teaching them, just like the maths skill. And just as you would for teaching a maths skill, you need to check that they're doing it properly, and you need to insist that they draw the diagram alongside their working as you do the maths. Otherwise, they won't practice it and they won't transfer it into the assessment, which is really important for their success. Finally, our strongest finding is that the students who don't have a method, or who've really struggled with traditional methods at school, and you've got to remember these are students who've come out of GCSE with a grade 0 to 2, these students are much more likely to even try to solve a problem if they've learned how to picture the information on a diagram. So this is really empowering for them, and it gives them access to much more of the assessment. That's it from us. If you have more questions, please put them in the chat.